All right, so completing a square really depends on your ability to recognize something like this over here, that you have an ax plus b, and that would equal, if you squared it, let's write that down, it would be a squared, x squared, plus, well, then you're going to get abx, so 2 abx plus b squared. All right? So what does it depend on? Recognizing squares. I mean, it really does. So the first thing I do is I recognize this over here. And to do it, and again, I'm not saying that everyone does the same thing, but 4x squared plus 2 times 4 times 3x. Whoops, that's not a plus sign. Sorry about that. Now, someone said, why'd you do that? I needed to get the 2, and I need to get that 4. What's left over? The 3. So to complete the square on that, I actually have to add 9 squared on. All right? So you'd have to add, I'm not squared, 3 squared. So that'd be a 9, right? So that's where this is coming from. All right? Now let me repeat this. If you add 9, you must take 9. But there was already a minus 7 there. All right? So what do you get over here? Something pretty simple. The first thing is a perfect square, and it's 2x minus 3 squared. And then you get minus, well, that's minus 16. Then what do you have? Right now, you have a difference of perfect squares, which is 2x minus 3 plus 4, 2x minus 3 minus 4. Simplify, 2x plus 1, 2x minus 7. That's what's listed over there. I got to be honest with you, though. I would not have done that. What I would have done, I'm sure you can predict me by now, I would have just given it a try. All right? And I'll point out what I mean by that. I'd look at it and say, gee, I wonder if it works. What's nice about the 7? There's no choice. It's got to be 7 and 1 for that. The 4x squared gives me choice, though, but I'm kind of looking at it, and I'm going to say 2x and 2x. And then I'm going to say this over here, and then I'm going to try it. You certainly get the 2x squared. You certainly get the minus 7. Do I get what's in the middle, which is minus 12x? Well, look at it. Whoops, I made a mistake. Sorry about that. Do I get the first term? Yes, 4x squared. Do I get the last term, minus 7? Yes. Do I get the middle? I don't know. Well, that gives me 2x minus 14 minus 12x. Bingo. Right? That's another way of doing it by just looking for trial factors. Let me just erase this over here. I did it 2 different ways already. I want to describe a third way, which is the way that I'd really do the completing the square in the problem. So I'll write this down for you. For me to do the completing square, I actually prefer to get the coefficient on the square to be a 1. This would be x squared minus 3x. Let's not worry about that so much. Minus 7. I can hope you agree that these are the same thing. All right? Now what I mean by that, that gives me 4x squared minus 12x minus 7 if I remove the grouping symbol. The next thing I do is take half of this number, which is minus 3 halves, and square it. What do you get over there? You would get 9 quarters. Now someone says, what did you just do? Well, I want to point out what I did. I actually added 9. And why is that 4 times 9 quarters 9? That means you got to take it. Okay, and again, if this confuses you, don't do this method either. What do you get over here? 4. This would be x minus 3 over 2 squared minus 16. All right? Don't be alarmed yet. All right? This is the difference of perfect squares. All right? And really, it's just looking straight at it. What do you get over here? 2x minus 3 halves minus 4, 2x minus 3 halves plus 4. Let's simplify that. What do you get? 2x minus 3 minus 4 is minus 7. 2x minus 3 plus 4 is going to be plus 1. Do we get the same result? Of course we get the same result. So 3 different ways of doing it. Your mileage may vary, by the way. All right. So, yeah, we're done with that one. Thank you.